Questions for today from the beginning of time. Very large telescopes and a black hole from the earliest universe. I'm Tonya Hall, and joining me is Roberto Gilli, first researcher at the Astrophysics and Space Science Observatory of Bologna. Welcome, Roberto.
Thank you very much. Hi.
What are some of the projects in which you engage at the observatory?
So the main project I'm being involved in my research at the observatory is searching and possibly finding black holes, supermassive black holes in the distant universe, including those at the the highest redshift we know, so at the largest distances we know in the universe, and also including those which are most difficult to detect. So the ones which are obscured by clouds of dust and gas that prevent our instrument to effectively detect them.
You and your team made an important discovery recently using the very large telescope of the European Southern Observatory in the Chilean desert. Tell us about galaxies surrounding a supermassive black hole.
Yeah, so actually, let me just say first that besides the very large telescope in Chile, we also had to use many other very large telescopes distributed all over the world. For instance, we used the Keck telescope in Hawaii. We also used the LBT telescope in Arizona, because it took many years and many big facilities to be able to measure the distance of these galaxies. So essentially what we discovered is a series of galaxies. At the moment we discovered 6, but we suspect there are many more that are surrounding a black hole that is very large. Its mass is estimated to be about 1 billion solar masses. And this black hole is already in place when the universe was actually very young. So the age of the universe, when the light was emitted from that black hole, and then we can observe it, is about 1 billion years, which is a pretty young age for the universe. So we were facing a mystery that astronomers try to explain since about 20 years. That is, how is it possible that such gigantic black holes exist in the early universe? Because they are too big, essentially. We suspect that supermassive black holes accumulate most of their mass by accreting gas from the surrounding medium, but this growth must be extremely fast to explain such systems discovered so early in the universe. And so one possibility that people were thinking about is that these systems must live in environments that are particularly dense, meaning that this high density of galaxies and of gas surrounding the black hole is favoring actually the feeding. And so what essentially we demonstrated in our study is that actually this is true. So objects like the one we studied actually do live in overdense environment. So they have the necessary reservoir of gases surrounding them to feed them and to make them grow to their final masses. The galaxies we observed are exactly the signpost telling us that there is a dense, large-scale structure around the black hole.
What is the strength of the signals that you have to capture to understand what you see and detect?
You mean what is the specific measurement that we need for confirming it?
Yes.
So essentially, what we need to measure is what is called the redshift of the objects. We know the redshift, which means the distance of the black hole. And among all the objects that we see in the same region of the sky, we have to search for objects at the same distance as the black hole is. And so we have to use such big telescopes like the VLT, the Keck, and so on, to get optical spectroscopy of these systems, and through the wavelength at which we see the Lyman alpha emission line, essentially, we could estimate the redshift and in turn the distance of these galaxies. And our observations actually showed that six galaxies that we selected as good candidates to be at the same redshift of the black hole actually have a Lyman alpha emission that tell us that are really at the same distance of the black hole. And so we measured a group, or let's say a large-scale structure made of galaxies surrounding the black hole. What we think is that this structure may eventually evolve into what we know now as the big galaxy clusters that we observe in the local universe. So probably this group of galaxies, which not only contain the six we measured, but likely contain many more galaxies that we still have to discover, but we have candidates. So this structure will probably later on collapse into a very big and massive galaxy cluster.
This redshift must be some of the most extreme of any object detected at today, right?
Yes, it is one of the largest. It's not the largest one. For a supermassive black hole, we know that the most distant redshift is about 7.5. This is 6.3, is slightly lower, but still this object is one of the most distant quasars, most distant supermassive black holes that we know to date.
What lessons about our universe today does this discovery help teach?
Well, I think that possibly, rather than teaching us lessons, probably opens further questions, because what we discovered is in line with the theory. So we probably confirmed that such massive systems do live in overdense environment. They have gas around them that could be used to feed them and to make them grow. But again, the existence of such large structure and such big black holes early on in the universe is something that we have still to fully understand from a theoretical point of view. So I think that at the moment, we probably accommodated a little piece of the theory, but most of the theory has still to be really nailed down by observations.
Roberto Gilli, first researcher at the Astrophysics and Space Science Observatory of Bologna. Thanks again for joining. If somebody wants to connect with you, Roberto, what's the best way they can do that?
I think they could either go to the web pages of my institute, the Observatory of Bologna, or just drop me an email at my institutional address. This is roberto.gilli@inaf.it.
Thanks again. And find more of my interviews right here or at tonyahall.net. Thanks for watching.